When I was teaching tractability for the Level 3 Computer Science standard, I wanted the students to be able to practice finding an optimal route problem with a context that was meaningful to them. So what I got them to do was find a route between classrooms in the school. The context, we have student runners who go from classroom to classroom with notes, and finding the optimal path to do that. So I used Geogebra as the tool for this, and this is exactly what it was. So the students had a bunch of classrooms, they click a button and it tells them how far it was, and they just Control Z backwards out of that and find a different route. It was very easy for them to take screenshots and provide evidence of their practice. So I'm just going to show you how to set this up for your own context or scenario. So starting from scratch, the map is just an image, so you need to use the Insert an Image tool. I have had a school map handy. For this particular one, I went into Google Maps and I took a screenshot of my local area. So while it just waits and finds, there we are, eastauckland.png. There's just a map of the local area. Now there are a couple of things that need to be done to get this working. Say I had a bunch of points that I wanted to use for my problem. If I just do it like this and then use the mouse wheel to zoom in and out, you can see they lose the frame reference there. So we need to actually fix the image to the coordinate grid. So if I just right click, I always have to click on the pointer first, right click and object properties and go to position, you basically specify the position of each corner. I happen to have clicked in the bottom left as -4, -6, and looks like for the top left it'll still be -4, but I'll put it at 6, looking at that little bit of the grid that I can see, the axes that I can see there. So now if I put some points on and zoom in and out, they stay fixed, so that's much better. I also need to have a button, I think, to actually do the calculations. So under here, insert button, I'm just going to click over here. This is where I'd like the button to be. There we go. And it's going to be, I'm going to say calculate distance maybe. There's a little bit of a formula that you need to type in. So the name of the things that you want them to see, I'm just calling it distance, and it's the perimeter function. And the polygon is always called poly1. So apply that. So now I've got a button here. While I'm here, I'll just make that a bit bigger so we can see it. Object properties and text. We'll make that very large. Right, so now I will put some points in place. 1, 2, 3, 4. Choose the polygon tool. Find a path. Optimal path, I think, in this case. I have to change my cursor so I can click the button, and it was 15.87. That's obviously not got any meaning in terms of the scale of this map. It would be possible to make the scale map match the map scale, but the students never seem to mind about that. So that's pretty straightforward to do, and the students get pretty quick at Control Z back out of that and then try a different pathway. Maybe this one will be better, and change the cursor and click the button. They get good at doing that. Oh, it turns out not. So very straightforward to set up. The last thing is, of course, that you can then upload it to Geogebra Tube. You just need to create an account and then upload the .ggb file that would have been created when making this here, and then that makes it very easy for the students to use. They can just run it in any browser that has Java working. And that's it.